Welcome to the demonstration of OpenL Tablets tables. We'll be discussing how to develop a table using the OpenL syntax and viewing demonstrations through WebStudio. If you've not viewed the WebStudio Basics video yet, you should do that prior to reviewing this video. Now we're going to discuss a specific type of table, which is a data table. Data tables are used to store or organize relational data. We use the keyword data. There's two types. There's simple data tables and advanced data tables. Right now we're going to focus on the simple data tables that you use to create a list of data that uses a predefined data type. Also, it's very important that you use the required keyword this in your data table. This will indicate to OpenL that the data table is a simple data table type. So let's look at this example. In the header, we have the keyword data table. Then we have the data type, which is int for integer, and we'll discuss that in the next slide. Then we have the name of the table, which we named numbers. We then have in the next row that keyword that I told you was important, which is the word this. Then we have another row, which is just for descriptive naming purposes and readability, so analysts can read the table. And then directly below, we have the list of integers or the numbers that we want to use in our module, 10, 20, 30, 40, and so forth. On the other side, we have this advanced example, which we're creating a custom data type or data structure for a person, which will collect a person's information, which will include both their name and social security number. The advanced data table is very important as you are going to use this a lot as you test your rules. The advanced data table uses the keyword data, but then it uses the name of the custom data type that it is going to use, and then you have the actual table name. So in this example, the advanced data table is the data person P1 table that we have listed there, and data is the required keyword. Person is that custom data type that you're seeing in the table above it, and then P1 is the table name. Then we have the second row, which indicates the data attributes and values. The third row is for descriptive purposes, and then the fourth row and further contains data values, and each row is a particular data object. So you can see how we can create a complex data structure using these advanced data tables. In a later slide, we will discuss the data type, keyword, and table in detail. Data typing is a critical step in creating a rules project, as well as key in understanding a project and its values. When you first define the data that will be in your project, you must also define the type of data that it is. It is in this step that tells OpenL what the data will be used for and how OpenL should use it. When first mapping out the data model for a project, a specific data type workbook or worksheet should be created which relates to the data coming in from a separate application. For instance, in a rating project, data will be defined for risk items or coverages. This is the same data which is captured in Policy Core and sent to OpenL to process premium quotes. Each data element must have a data type, and you can create custom data types for groups of data elements which make a custom data type. For example, address is a custom data type that can be created by listing multiple data elements such as street and zip code, but the data element street is a string and zip code is a string. You might have thought that zip code was an integer because it's a whole number, but we don't perform math operations such as addition or subtraction on a zip code. Also, if you define the zip code as an integer and the zip code had a leading 0, OpenL would remove the leading 0 to resolve the value as an integer. So you can see how the data type defines the meaning of the data and instructs OpenL how it can process and what it should do with that data. So there are two types of data options that are available. You have your predefined data types, which are standard data types that you can use immediately and is offered via OpenL, and the syntax is there. So we're going to discuss that. If you're familiar with programming, these are your primitive data types. An example would be age is an integer that can be subtracted, multiplied, or divided. But then we have custom data types, which are the ones that you can create this data structure, this object, by combining multiple data elements and their associated predefined data types. For example, the address that we just spoke of combines a street number, which is an integer, and a street name, which is a string. So we've discussed how important it is to spend time creating your data model and also making sure that your data model is typed correctly and that you're creating custom data types to support your project and that they're typed properly. Now, in this example where you see two different tables, which are both data type tables, one is policy and the other is vehicle, you'll notice that in the policy table there are two custom data types, driver and vehicle, which actually are arrays in this data type table. Now you'll see we have a custom data type called vehicle below where we've created that custom data type for this project, but in the policy data type table, vehicle can be an array, and that means that you can have multiple vehicles for a policy. And you know, in an auto insurance policy, you could have multiple vehicles on one policy. So this creates this hierarchy of data and the possibility to store more than just one instance of a data type. So here is a listing of the predefined data types that you can use in OpenL. They're listed in the reference documentation, so you can always go there to see a complete listing. But the simple data types that you can use to define what type of data is in your tables are integer, double, big integer, big decimal, string, boolean, byte, character, short, long, and float. For value data types, which are the same exact thing as the standard data types, but when you use them, you can actually debug your rating project. So what will happen is if you use this data type, when you're doing any testing, it'll create a link to the source of the data in WebStudio. Again, and you use all the same data types from simple, but you just add the word value at the end. So it would be integer value, double value, big integer value. And then lastly, we have range data types. And you use those when the data value represents a range or group of values. So we have two that you can use, which are int range for you have a range of integers, or double range. Besides the simple data types that are offered to you through OpenL syntax, you also have custom data types that can be created. The ability to create these custom data types allows you to combine different data like we talked about before. And the syntax you need to use in the table name, you need to use the word data type, and then you name the table whatever name you want to name it. For example, a person's data type can be created using the following elements, which are name, social security number, date of birth, gender, and marital status. Each one of those data elements you'll see has their own data type. whether it's string or date. So after you create this data type, it kind of becomes a container or a way to pass a set of data into an OpenL other table or function. If you think about the person data type here, if we were using policy core and rating implementation of OpenL, you could think about that a specific person's information was used for quoting a policy, and that information was stored in this data type that's person. And now in OpenL, you can use this data to run all sorts of different conditional logic against, let's say, the date of birth or the gender to come up with different values and results that you need for your rules development. On the slide, you see that there are two tables for person. One is just demonstrating when we create a custom data type. The second one with the 3 columns shows that you can actually default any of the attributes that you have in your data type by adding a 3rd column and entering what a default value for that attribute should be. Also, there's an alias data type which allows you to set the predefined possible values, and the syntax that you use is the word data type, the name of your table, but then actually you put like the data type, whether it's string or integer, and then you have your listing of data type, and this is very useful. Because you can use an alias data type in tables, and OpenL tablets checks to ensure values match the values from the alias data type table. If a value does not match a value in the alias table, then an error is displayed for the user. When working with data tables, you may want to check or verify your data's integrity, or use data from a different table so you don't have to duplicate the data in 2 different tables. We have 2 different methods here, and you'll want to reference the OpenL documentation for further listing of functionality and syntax. But first, a data table can check its values against values defined in a different data table by using the syntax here. If you use the bracket sign and then the reference data table name and also then the column name of the data table that you're checking against, you can see in this example, WebStudio will check the states table to make sure the code listed in the cities table has a match in the states table. Besides doing validation or checking, you can also use this syntax to construct complex objects within a table when some data is defined in another data table, so that the first data table does not duplicate the data, but references the second data table to get the required data. So then we have a secondary type of data integrity you can do, where you can actually use the data from another table in your table, so you don't have to duplicate the same data in multiple tables. You can see, again, we're using brackets for our syntax, and then using the reference data table name, and then a dot, then the attribute name, and the column name. So if you look in this example, the vehicle column in the claims table points to the first columns in the policy table. You may also write some syntax to reference another table, but you can leave out the column name, and what will happen is OpenL will just use the first column in the table you're referencing to retrieve its value. We are now going to do a demonstration of data and data type and alias tables. But first, we're at the OpenL tablets website, where you can actually find some of the tutorials that we're going to use in our demonstrations. Underneath of the documentation, you can select tutorials, and you'll see that there are tutorials about the different OpenL tablets tables that you can use to learn more. So now I actually already loaded Tutorial 2 Introduction to Data Tables into WebStudio, and we're going to do a demonstration. I'll select under Projects, Tutorial 2 Introduction to Data Tables, and then in the folders I will expand both the data and the data type tables. So the first thing I'm going to do is we're going to create a data type table so you can see how this is done. I'll use the Create Table button. It will bring up a wizard for me, and you can see the types of tables that you can create using this button. The data type table, the data type alias table, a data table. Then there's some other tables, test table, properties, and simple rules, which we won't be doing right now, but it's good to note that you can create these types of tables through this wizard. So let's first create our data type table. It's already selected. I'll select then the Next button. Then I'm going to enter a name. I'm going to call this Person Example, and I'm using camel case with a capital letter for the table name. Now, if I wanted to inherit some other table's data, I could actually use the parent drop-down box, but I'm not going to. I'm going to select Next, and then it's going to ask that I add table parameters, and really these are attributes. So I'm going to actually create an attribute called name. Now, name is not a big decimal. Name is a string, so I'm going to select name from the type drop-down box, and then I'm going to select the add parameter button to add another attribute, and I'm just going to say this is address, and again, that's not big decimal, that's string. So I'm going to then select the simple data type that I want to use, which is just going to be string for this example. Now I'm going to add one last attribute, which is gender. But you can see over here, gender is a custom data type that was already created in this example. I'll select gender, and then I'm just going to use the attribute name gender again, and I'll make it just example. Notice how I started it with a small letter, so you can easily see that this is an attribute name later when you look at the table. And then I'm actually going to select the Next button. So then it's going to ask me where I want to actually store this table. And it's asking me if I want to store it in the main module, and then what category, which is your different worksheets in your workbooks. You can see that we have 4 different worksheets in our workbook. I could actually create a new worksheet or in our workbook, which I'll show you. In WebStudio, it's called a category. I'm just going to call it example category, and you'll see later how it actually becomes a worksheet in our workbook. But I selected new, and then I'll select save. Now you can see over in our data types, I have a person example. This is the table that it created. I'm going to actually now create a data table using this data type person example. So again, I'm going to use the Create Table button. This time I'm going to select the data table. I'm going to select Next. It's going to ask me the table type and name. I'm going to look for the data type that I created, and there it is, person example. And then it's going to ask me for a name of this table, and I'm just going to write people. I'm going to select next. Now up here, it's asking if I want to change the name of the display of the table, which I can, and I'm just going to put here so you can see this as an example. I'm going to put the word display. And then I'm going to select next. And then again, it's going to ask for a destination of where I want to save this table. And I actually want to save it in my example category. So our data type and our data is going to be on the same worksheet. We're in the same category. So now I've saved the table, and you can see I have a person example, a data table called people. I have the name, address, and gender example, but then I have the display names in the third row. I'm going to now select the edit button because I'm going to actually want to add data to that now. All we did was set up this data table. Now in order to add actual people or data to this table, I'm going to select edit. Then I'm going to select on my last column, which I could actually change if I needed to change the display name here. I could just put display X just to see an example. But now I can use this insert row, which is going to actually insert a row where I can put my data. So I can put name, and I can start to enter in WebStudio. Now in my gender, I can only have male or female because that's a gender type that has an alias data table associated with it. And my only two options are male or female. But if by accident I type in something by mistake that isn't male or female, I'm going to show you how OpenL will show you an error to help you correct that mistake. Now I'm going to insert one more row. I'm going to make this okay. Now I'm done, and I'm going to select Save Changes. Now I have an error. You can see that WebStudio has now told me that the object make is outside of a valid domain. So then I can look at my table and I can say, okay, here's make. So to edit it, I can just double click on it, and now WebStudio is going to give me a drop down box where I can select either of the options available in the gender data type. So I'm going to select, this was actually female, and then when I'm done, I can hit the Save button. WebStudio will then validate my table, and now that everything is okay, I've saved my table. Now I want to look at gender so you understand what an alias data type looks like. I will expand data type. I'll select on gender. And you can see that this gender alias table has male and female in it, and that's where WebStudio is getting those values. Now I'm going to actually open up the Excel workbook associated with this project. And let me size this for you. But notice now I have down below the different worksheets in our workbook, and example category is now a worksheet. And when I select on it, you can see my data type person example table that I've created, and then also, just make that a little bit bigger, the person example data table of people that I've created with my 2 different people in it. So that is a demonstration of data tables, data type tables, and alias data type tables. And that concludes this part of the demonstration.